All right, everybody, let's welcome back to lesson 3 of our fair division chapter. This is what we call the lone divider method. If you think about the lesson we just learned, we learned what we call the divider chooser method, and that works really well when you have two people. So in this case, we actually have, let's say, we have more than two people. So, what are some ways that we could fairly divide, given that there are more than three people, or three people or more? All right. So, this first one, our method for three players is what we call the lone divider method. And so, what we do is we're going to assign one of the players to be the divider. We're going to call them D. And they're going to divide the goods into what they think, once again, it's their perspective, what they think is three fair shares. Okay. So in their mind, the divider is always going to think in terms of they're always going to want each piece to be a third. Because once again, they have no say in what piece they're going to get. So they want to make sure of the three pieces that they're all equal in their mind so that they're happy no matter what. And then you're going to have the two choosers. And that's where they're going to make a bid on which pieces they want. And that's the whole bidding process. And it is deemed a fair share if they have more than 1/3 of the value. If it is less than 1/3 of the value, then it would not be a fair share, right? Because if there's three people, then they each want at the fewest 1/3 of the share. And then last but not least, then you're going to make the distribution. And shares are given to players based on their bid list. So once again, if you value something more than something else, then that hopefully will be the one that you get. But no matter what, you're always going to make sure you get at least your fair share. Okay. Which would be, once again, if there are three people, at least a third of the objects. In this case, cake or pie or pizza or whatever that you're dividing. All right, so let's look at case number 1. Each chooser can receive a different fair share from the bid list. You always want to shoot for optimal distribution, that every player wants to maximize their share of the booty. All right. If possible, players will receive the more preferred share, but okay with anything that is fair. Okay. So basically, when we talk about optimal distribution, we're saying um, if possible, all right, if possible, players will receive more receive the more preferred fair share. But will always get a fair share. Okay. So in this case, they will always get 1/3 of whatever they, at least 1/3. They might actually get something that's valued better, but they will at least get 1/3 because there are three players. All right. So let's look at an example here. Example number 1. This would be case 1. So we got three siblings. Dell, Cindy, and Claire are dividing their backyard into three pieces of land. Determine which piece of the backyard each sibling will get. All right, so we can kind of tell in this regards who is our divider. Who would be the divider? Well, in this case, Dell is our divider. Now, how do I know that? By just looking at the bid list. Well, if you notice, Dell deemed everything to be worth 33 and a third. Okay. That's 1/3. Everything he thought. So, because once again, he doesn't want to lowball something because that might end up being the one that he gets. So he wouldn't, that would, kind of defeat the purpose of getting your fair share, that you would always want to at least break it up into what you deem is an equal third. So that way you're always going to be happy. So Dale is my divider. And Cindy and Claire, so once he divided, they came in and said, okay. So like Cindy said, well, the first piece of land, it's like a 35. Okay. The second piece of land, she said, was only a 10%. But the third piece of land, she gave 55%. And then so on and so forth. Claire was 40. And Dell, or the second was 25. And the third piece was 35. Okay. So we got to think about first, we want to make sure everybody gets their fair share. So if you think about it, Dell is okay with 1, 2, or 3. Okay. Cindy is, in terms of fair shares, 1 and 3 would be a fair share. And then Claire, I'm going to do CL for Claire. Claire, 1 and 3 was also the best for Claire. Now, if you think about it, well, nobody outside of Dell gave any value for the second plot of land. So we can go ahead and say Dell should get plot 2. All right, so now we're down between Claire and Cindy. And if you notice, Cindy gave more value to plot 3. And in terms of all the plots, Claire gave more value to plot 1. So we're going to give Cindy plot 3, and we're going to give Claire plot number 1. And that way, everybody gets their fair share. Okay? So if you really think about it, if a fair share is 33 and a third percent, then in Cindy's mind, she actually got way more than a fair share. And Claire also got more, maybe not as much as Cindy did, but Claire did get more in what she thought was a fair share. So this is how the lone divider method works. So that was example 1. Well, let's look at example 2 here. Our case 2 shows us we have one little conflict. And what if the divider gets a share that is unfair to both choosers? Okay. So what if when we divide it out, that the other 2 shares they don't like, and the 2 choosers are choosing from just the same list or same plot. In this case, they switched it from land to pie. So now the 3 siblings are dividing a pie that their grandmother baked for them. Determine which piece of the pie each sibling will receive. So if we do the same thing we did before, Dale must have been our divider, because everything is 33 and a third. So in terms of our bid list, Dell is going to get S1, S2, or S3. Okay. But now when it comes to Claire, or to Cindy, I should say, Cindy, the only one that she deemed to be fair, because once again, remember, fair would be 33 and a third. The only one she deems to be fair would be the third piece of the pie. And then Claire, same thing. No. Claire, the only one that she deemed fair was also that third piece of the pie. All right. So what are we going to do there? Well, so what we're going to do in this case is we're actually going to almost create a divider chooser scenario. So the first thing is we're going to give Dale his piece. And what we want to do is we want to give him the piece that mutually was the least desirable. So if you think about it here, Cindy and Claire did this one as 30%. This is 50%. Okay. So this is the least desirable one. So we're going to go ahead and give Dale S1. That is the least preferred. Okay. We're going to go ahead and give Dale S1. And now what we're going to do is we need to almost, if you can imagine, we're going to push the pie back together. I mean, it is just a piece of pie, so we can kind of do that. So we're going to put the pie back together. So in that regards, how much for Cindy, then the pie is worth, because we did 2 and 3 back together, is worth 30 and 50, which is 80%. Okay. And then Claire, if you put the pie back together, 20 and 70 is worth 90% to Claire. So if you really think about it now, if we split that in half, okay, if we split that in half, then what piece, what would be the minimum that Cindy would receive? Well, Cindy would get a minimum of 40. If you think about if you cut it in half, and Claire is going to get 45%, would be the least that she thinks that she would get. The 45% of the original. Because think about it, because what we're doing here is it's going to become basically a divider chooser kind of thing. So they're going to take that last piece and they're going to, one of them is going to split in half and the other one's going to take. So Cindy's going to at least get 40% in her opinion. And Claire, if she was the divider, would end up getting 45% no matter what. All right, so there's our first examples of the lone divider method. All right, so what if we have more than 3 players? Well, we're going to kind of generally do the same idea. So in this case, if we had, let's say, 4 players, we're going to have basically one divider, and then you're going to have n minus 1 choosers. Okay, always. The division is going to be, if you, depending on the number of players, it's going to be 1 divided by however many players that you have. Your bidding will be the same, and then distribution, once again, based on what they bid. So